The next point is law of parallelograms gram of vector. That law is the another geometrical method of addition of vectors. It states that follow: if two vectors of the same type originating from the same point are represented in the magnitude and the direction by two adjacent sides of the parallelogram, the resultant vector is given in the magnitude and direction by diagonal of the parallelogram, starting from the same point as shown. Or you can use this statement also. If two vectors acting simultaneously on the particle are represented in the magnitude and the direction of two adjacent sides of the parallelogram drawn from a point, then their resultant completely represented in the magnitude and direction of the diagonal of this parallelogram drawn from that point. So let us see here. So in the exam, sometime they have asked to find out the expression for the resultant and the direction. So you have to or the proof of the law. So let us find out the expression for the resultant. So check here, vector P and vector Q both are, there are two vectors. Vector P and vector Q are the two vectors. So sorry, vector OA and vector OB. OA or OB. So vector OA is equal to vector P and vector OB is equal to vector Q. OA is equal to P and OB is equal to Q. This is the magnitude of the vector. Both vectors originating from point O. So if you find out the tail of both vectors P and Q, that will be O. So they are originating from point O. And there is some inclination between them. That inclination should be theta. Okay, so the angle between vector P and vector Q is theta. Theta is the angle between P and Q, vector P and Q. Now, if we complete the parallelogram, so actually this is your figure. Then draw parallel side for OP and parallel side for OA. You can complete the parallelogram by this way. Then the resultant OC will be the diagonal OC will be the resultant. And our interest is to find out the expression for this resultant. That means this resultant is the force or the has the same effect of vector P and vector Q, addition of these 2 points. So first of all, to find out vector R, Okay, to find out vector r. So that we had done uh, some geometrical changes in the diagram. Draw perpendicular from point C to vector OP. So this is the perpendicular. As that perpendicular comes outside, you have to extend vector OA, and then that perpendicular touches the point at M. Okay, so now there are two right angle triangle. So first triangle is OCM. This is the OCM. So using Pythagoras theorem, you can find out vector OC square is equal to vector OM square plus equal to vector CM square. So OC square plus OM square plus CM is equal to OM square plus CM square. But if you will see that OM is made up of vector OA and AM. So you can use instead of OM here. That means OM is equal to OA plus AM. OA plus AM. So you can add this. Okay. Now expand this bracket, then you may get OA square plus 2OAM plus AM square plus CM square. AM square plus CM square. Check it. AM square plus CM square. So AM square is the side of the triangle CM. Okay. Concentrate on this term. That AM square plus CM square is the another sides of the another triangle OCAM. So here AC is the hypotenuse of this triangle. So instead of writing this, you can write here AC square. Okay, so OA square plus 2OAM plus AC square. Then 2OAM plus AC square. But OC is your resultant. So this is equal to R. OA having value P and AC, as AC is parallel to OB, has value Q. So you can use vector R is equal to vector R is equal to, say, P square plus Q square plus 2 PQ plus 2 PQ. But one factor will be there, that is cos theta. How? Because AM has not actual answer. So you have to substitute something for AM. And that AM is nothing but, you can find out the magnitude of AM by simply trigonometry. So cos theta is equal to, for CM, for this triangle, cos theta is equal to AM upon AC. So it will be equal to AC cos theta. AM is equal to AC cos theta. So that AM instead of AM, AC cos theta is there. So your resultant will be r square is equal to p square plus 2pq cos theta plus q square. So if you take its square root, then this will be the value of r. One can find out the direction of the resultant, and for finding out the direction of the resultant, you require tan theta. First of all, find out sin theta. Sin theta is for CM, sin theta for this triangle, sin theta is equal to CM, opposite side upon hypotenuse. So this CM upon AC, or CM is equal to AC sin theta, and AM is equal to AC cos theta. Now sin by cos is equal to tan alpha. That will be CM upon AC, CM upon OM, and that OM is equal to OA plus AM. OA plus AM. So AC sin theta plus OA plus AC cos theta, that is tan alpha is equal to Q sin theta upon P plus Q cos theta. So that will be the direction of the resultant.